Welcome to VKS Coding. In this video, we'll talk about the design and notification system. So this will be the high level design for notification system. So basically a notification system already has become a very popular feature in many of the application in recent years. And a notification alerts a user with important information like breaking news, product updates, event offering, and many other things. And in notification system is just more than mobile push notification. There will be a multiple type of notification formats. There will be a mobile push notification, SMS, email. So here I have given the couple of example. Like for push notification, there will be your Amazon package is delivered, or it is out for delivery. So this kind of push notification can be sent to a mobile, right? And second type of notification will be the SMS, like we get a offer, something like Big Bazaar having a purchase of 2000, you will get back 2000, something kind of offer is going on in Big Bazaar or like Brand Factory. So this kind of SMS we also got, and in email also, this is also a type of notification. Like some discount is having a purchase of 500, you will get 500 back, or purchase of 2000, you will get cash back of 1000 rupees, like that. So these having the different kind of notifications. So let's proceed further and we gather the requirement for the notification system. So we can ask the couple of questions to the interviewer to clarify the requirements. So first question will be the what are the types of notification does the system support? So interviewer can say the first one will be the push notification. Second one should be SMS, and the third one is email. We can ask one more thing is like, is it a real time notification? Real time system means whenever the event is triggered, it should be delivered as at the real time, or how it can be. And let's say interviewer is saying it's a soft real time means if the user receive a notification as soon as possible. Otherwise, if the system is under a high workload, it slightly delay is acceptable in high pressure, right? So we can say that it's a soft real time. So basically, in high load, okay, that time it will be slight delay is possible, and as soon as possible, we want to deliver the notification. And other question we can ask like, what are the supported devices, right? So interviewer can say they want iOS, Android, SMS, email. So these kind of supported format of notification interviewer is going to want us to design it. Next question we can ask, what trigger the notification, right? Then interviewer can say notification can be triggered by the client application. They can be also scheduled by the server on the timely basis, but let's assume here this can be scheduled by the client application. Means client application will schedule the notification. Then we can ask, will the user be able to opt out the notification? Interviewer can say yes, because if in sometimes what happens, there will be too many notifications coming to a mobile email, then we get the option to also unsubscribe kind of option, like that. So that is called a opt out feature, like opt out or unsubscribe feature. So this we have to also design it while designing the feature. And how many notification can be sent out for each day, we can ask for the interviewer, like what is a daily active user. So interviewer can say, suppose 10 million mobile push notification, 1 million SMS, and 5 million email. So these are the requirements. First one is the type of notification will be the push notification, SMS, and email, and it could be a soft real time means as soon as possible we have to deliver it. On the high load, slight delay is acceptable. And the devices, the supported devices are Android, iOS, SMS, and emails. And who trigger the notification? Client application will trigger the notification. And will the user will have a option to opt out or unsubscribe the notification? Yes. And these are the daily active user for mobile push notification, SMS, and email. So for a mobile push notification, 10 million, SMS 1 million, and for message email will be the 5 million. So let's proceed further and first try to understand Let's first get the idea of different kind of a notification first. Now let's proceed further and understand the different kind of notification. So first one is iOS push notification. So let's first discuss about it. So we have a provider here that is nothing but a client application which send a notification to the Apple push notification service, and this Apple push notification service will send the that notification to the iOS devices. So basically, when the provider send the notification request to the Apple push notification service, so it will send it to the device token to identify the device token, and the payload, like what is the notification message will be there. So that two details will be sent it from the provider application to the Apple push notification service, and that will deliver to the iOS devices. So this is the first kind of iOS push notification service. And second will be the Android push notification service. So let's discuss about the Android one. So in Android, in place, so it is similar to the iOS only, but in place of iOS, that push notification service we will use here is the Firebase Cloud Messaging service, or a similar kind of a service will be commonly used to send a push notification to the Android devices. So basically, provider is again some kind of a application like any business system or anything which will send the message to the Firebase Cloud Messaging Service, and this messaging service will send the notification to the Android mobile apps. So this is how it is going to work it. And the next will be, this is very simple because these are the third party component, right? These are the third party service which is like we have to integrate it in our design. We don't have to design it from the scratch. And this is the provider application, and this is going to send the message to the this Firebase Cloud Messaging Service is a kind of a remote service which accept the request and do the needful task on the basis of request. So whenever somebody want to send the Android push notification, it will accept the message and the details, and it will send that particular device to that particular message. Now the next one will be the SMS. So in SMS, there will be a third-party SMS service like Twilio, Nexmo, or many other are commonly used. So basically similar to the Android push notification, also here will be like SMS service like Twilio or something else will accept the request and will send the application this notification to this SMS to the mobile devices in the mobile. So this is the third kind of SMS message via we can notify the user, right? And the fourth one is kind of a email. So let's see the fourth one. So although company can set up their own email servers, but many of them opt for commercial email services like SendGrid or Mailchimp are the commonly and the most popular email service which a better delivery rate and yeah, definitely which provide a better delivery rate and data analytics. So in this also, this is the third party application, and the provider will send the email to this service, and this email service provider will send the email to that particular user in a desktop or in a mobile, like that. So it will be, the mail will be sent via this third party email service. So these are the four type of notification we can send it to the user. And now let's proceed further. But before sending the notification to the user, we need information about the user, like mobile number or the type of notification we want to send. Like user mobile number, we need it to send the notification. Like how we gather the information first, then we can only send the notification, right? So let's proceed further and see how we gather contact info for the user. So this is the basic diagram, like to gather the contact info from the user, and this is the flow. So basically when this is the desktop and this is the mobile for a user, whenever the user sign up or install the application, okay, that time it will go to the load balancer and to the API server, and the API server will store the contact info into the database. So this is very straightforward and simple. Whenever the user sign up or install the application, it will hit the load balancer, and from the load balancer it will go to the API server, and the API server will store the contact info into the database. So this is how we gather the information about the user. Now let's see the basic data model, how the contact info and the device info will be stored into the DB. So this is the data model for the user information and the device information. And in the user table, we'll keep the user ID, email ID, and the phone number. And the device info in the device will have a device ID, token, user ID. And for you one user there can be a many devices, so that's why I have represented here one to many relationship. So this is all about the data model, and now let's proceed with the initial design, and we plug those the third party services to send the notification in mobile or in the to the Android devices, iOS devices, SMS or via mail using third party services. So let's proceed and make the initial design. So this is our the first level design, and here are the services which is 1 to n, and services can be microservices or cron job or a distributed system that can trigger the notification event. And for example is like a billing system send a email to reminder to the customer for their due payment, or a shopping website tell the customer for their package will be delivered tomorrow via SMS. So this is the notification system, and the notification system is a center for sending and receiving the notification. And we are starting with the simple one notification system, and it provides the APIs to the these services, and it will build the notification, and it will send that notification to these third party services, which can further send the messages that notifications to these devices or the Android devices and the SMS or the mails. So basically, what happens is these services will call the REST API first, call REST API to the notification system, and this will send the SMS or this will send the iOS push notification, and this is for Android push notification, this is for SMS, and this is for email. So basically this notification system will send the according to the type of the notification to this third party services. Suppose it is having a SMS, then it will send it to the SMS service, and SMS service will send the SMS to the in the particular device. So this is the basic design, and these are the service, these are the application services which will send the events for notification, like these are the billing system or any other shopping application which will trigger the events for the notification system via the REST API. It will invoke the notification system, and the notification system will send the that particular notification to the relevant third party services. Suppose it want to send the iOS push notification, then it will send it to the application push notification service provider, and then particular service provider will receive the request from the notification system, and it will send to the particular iOS devices. So this is how SMS or a email or and means push notification will be delivered to the iOS and Android. But in this design there will be some problem, and what are the problems we'll discuss first, and then we'll improve our design. So first problem is the single point of failure. There is a single point of failure because there is only one notification system here. And second one is very hard to scale because the notification system handles everything related to push notification in one server. It is very challenging to scale the database, cache, and different notification processing component independently, because this notification having the DB and cache everything inside the one server. So it is very problematic to scale this notification system. And again, one more problem is the performance bottleneck, because processing and sending the notification can be resources intensive, and constructing the HTML page or waiting the response from the third party services could be a time taking. So handling everything in a one system can result the system overload due to the during the peak hours. So that could be also a problem. So we need to improve our design so we can overcome these problems. So what are the problems we have identified? Is the first one is the single point of failure, second was is the scaling, scale is a problem, and third one is the performance bottleneck. So these three problems we have identified with the design, and now we have to overcome this design. And let's see how we can improve our design. So this is the improved design. So in this design what we have done is, first is we have moved the database and cache out of the notification server. From here we have moved the cache and database, And we have added a more notification server. It is like it has a mini notification server. It is not only a single notification server, it is having a multiple servers. And the also we have set up the horizontal scaling, so it can scale whenever it need it. And we have introduced the message queue as well here to decouple the system components. So here we have also introduced the message queue. So here notification system is not directly sending to the this third party services. First it will put the message to the message queue, and from the message queue the server will pick up the message, and then it will transfer the request to the third party services, and then third party services will transfer the request to the that particular devices. So let's see one how the this flow will work. So first what will happen, these services will first send the event to the notification system to send a push notification to Android devices. For suppose in Android device, then what notification system will do? It will check the in the cache for the device info or the user info, device info or the user info. If it is present in the cache, it will return it from there. If it is not there, it will return it from DB. Once it has the details about that, it will put one message to the iOS message queue. So here will be one message will be put into the queue, and this server will be what it will does is this server will take the message from the queue, and it will send the that particular push notification to the relevant service provider. Suppose it is for Apple, then iOS devices, then it will send it to the Apple push notification service, and this push notification service will send the push notification to the Apple devices. So this is the way how the request will flow. From the first, the service will come to the notification system. Notification system from the it will come to the cache to collect the device and the user info. And if it is not present in the cache, it will take it from the DB. And once it has all the information, then it will put it into the message queue, and from the message queue the server will retrieve the message and form the notification and send it to the Apple push notification service. And this Apple push notification service is a kind of a remote service, will send the notification to that particular iOS devices. So I hope this is design is clear, and this is the improved design. And now can we improve this design as well, because there could be a some flaw, or we have to improve our design. Because how what will happen if the this server will unable to send the this particular message, or this message will be lost here, then how we can overcome with this problem. So let's proceed further and see how we can improve this design as well. So we'll discuss one by one about the problem, and later we'll improve our design. So for what will be the first problem is like how we'll gonna prevent our the database means the message drop. Suppose this worker threads is picking the messages from the this iOS queue, but it is unable to deliver to the Apple push notification service, because this Apple push notification service will send the that notification to the iOS devices, but it is unable to send it. Then what will happen in this case? What it will do? It will log this message. It will save this message to the notification log. So how to prevent the data loss? So we will add one more database here, which from in that database will save the notification message, and once if it is not delivered, we'll make a retry. So that is how we gonna prevent the data loss. So whenever the worker will pick up the message from the message queue, then first it will save into the notification log database, and then it will try to send the notification to the notification service. And if it is unable to send it, it will retry it. And once it is able to send it, then it will see further for monitoring how it can be done. Because once the message is delivered to the user, it can unsubscribe because they don't want those kind of a notification, or they can actually see the message. So those things can be also be tracked. Let's see few more points to be improved, like notification template we can also use. Like suppose the customer is having means notification is similar type, always we need to send it only the product name or something, we have to change it. So like that we can also save the some template, so we can reuse it and by customizing it. So let's discuss few point what can be improved. on this. So first one is a notification template. So users generally receive too many notification daily and they can easily feel overwhelmed, and many website and apps give the user fine grained control over the notification setting, and this information is stored in the notification setting table, like opt-in or something like that, like opt-in, what kind of services opt-in, like, so we can see this value and accordingly we can send it. And before sending any notification to the user, we can first check it is opt-in to receive this kind of a notification or not. So based on that we can do that. And next one is the yeah, this is for a notification setting, basically whether the customer has opted or not. And the notification template is a kind of a large notification system send out a millions of notification per day, and many of these notification follow a similar format, right? And the notification template are introduced to avoid building every notification from the scratch. And notification template is a pre-formatted notification to create our unique notification for customizing by parameter, style, tracking. Is like something is like your package for item, and there will be item name here, gonna deliver today. So something like this kind of a notification we can pre-build, and by changing the name we can use this notification template in every time. And next one is will be the rate limiting. So to avoid the overwhelming user with the too many notification, we can limit the number of notification completely if we see too often, right? So we can limit like 10 SMS per day, like that, something like that we can limit it. And retry mechanism I have also talked about in the when we talked about how to prevent the data loss. So whenever the third party service failed to send a notification, the notification will be added to the message queue for retry, and if the problem persists we will send out to the alert to the particular company or the developer, like it is not unable to send the messages, like if the third party service, right, this third party service, if the worker is trying to send and it is, if it is not working, it is not able to send, then we have in persistence, we will again put it into the queue, and from that again it will go to the same mechanism, and we will try 5 times retry, right? If it is unable to send, then we will generate a alert and will notify the company or particular developer. We can provide one more feature is like whenever the SMS is delivered or the notification is delivered to the customer, whether he's actually opening that message or it's like they are clicking on unsubscribe, they don't want further message from that particular events. So basically we have to define the event tracking. So let's discuss about that, how the event can be tracked. So event will be the first the message is started, and the second one it will go to the pending state. From the pending state, whenever we are trying to forming the notification, that could time also it go to error. And when we send the notification also it is not able to send, then it also went into the error state. Then when the SMS is sent, then it will become to the delivered state. And once the message is delivered in the client mobile application, is it opened the message or they have clicked unsubscribe after receiving that notification. So we have to track these states also, state, and what are the events are happening. So based on that we can generate the alert and monitoring. And we can also generate the notification metrics such as open rate, click rate, engagement rate are important in understanding the customer behavior. And analytics services also implement the tracking, and integration between the notification system and analytical system is usually required to understand the customer behavior. So I think I have discussed the couple of points. Let's try to improve our design with integrating the event tracking. And few points I have decided is like retry mechanism, rate limiting, notification settings, and the notification template, how to prevent the data loss. And more thing I have missed is authentication system, like whenever the user log in, the username password check, right? So that we can embed in the notification system itself. So now I think I have covered all the topics which should be there in the notification system high level design. So let's discuss all in very detail. And so this is the services in the left side, this is the services, and there could be from 1 to n services here, and this is the notification server, and this is kind of a mini server. It's not like only one server, so it is having many servers here, right? And it is embedded with the authentication and the rate limiter within the notification server itself, and it connects with the cache and the DB. And we have a queuing system also, so whenever the notification server receive the message, then it will put into the message queue, and the message queue will, from the message queue, the worker will pick up the message, and it will fetch the notification template and form the notification. Then it will persist into the notification log, that particular SMS, email, or the notification, and then it will try to send it to the that service provider. Here in this case, we are trying to send it to the iOS devices, so here will be Apple service provider here it. And we are also tracking the events, right? And we are sending to analytical services for event tracking and notification metrics. So let's see one flow and try to understand how it is working. So basically, first, what will happen, this service is like billing system or any system, it will send the event to the notification system. So first, this authentication and rate limiting will happen first. Then second, it will gather the device info or the user info from the cache. If it is not there, it will come to DB, and it is getting returned from here. And once the information is collected, this notification server also send the message state to the analytical service as a send pending. It means message is not yet sent. Then next, this particular event message will be placed into the iOS message queue. For each type of service provider and devices, we will have a different queue, but I have defined only one queue so we can discuss in detail. So now, once we have put the event into the queue, the worker thread will pick up the message. The worker thread will pick up the message from the queue, and it will talk to the notification template, and it will make the SMS ready, and it will save push notification in the notification log DB. So first, here it will prepare with the help of notification template, and here it will save it into the notification log. So once this is done, and once the worker node is trying to send this particular notification to the Apple service provider, then once it is sent, then it will update the status to the Apple Analytica service as a message as sent. If it is not able to send, then it will try to make a retry. How it will do the retry? The same message it will keep into the message queue. So again, the worker will retry the same operations, right? And once the Apple notification service will receive the this particular notification, it will transfer the notification to the iOS devices, and from the iOS devices, it will observing the click rates. What is it is going to open the message, or it is going to click on unsubscribe. So this kind of a event will be sent to this analytical service. So this is how the flow will work. So I'll explain one more time this detailed design, because this is our final design and we have to explain this design to the interviewer. So first, what will happen, this services can be of any application services which generate the events to send the notification, right? So these services will generate the events that will come to the notification service, and this notification service will gather the information to whom to send, and so it will collect from the cache. If it is not there, it will collect it from the DB, right? And it will send this state as a send pending to the analytical service. Then it will put the respective queue of the particular service provider from whom we have to send the notification. So in case of Apple, we have to send it to into put it into the iOS message queue, and from the message queue, the worker thread will pick up the message, and it will take the notification template, and it will prepare the message, then save it to the notification log DB, and then it will send it to the application push notification service provider, and it will update the status to the analytical service is the message is sent. Now application notification service, what will do, Apple notification service will send the notification to iOS devices, shows that notification is come to his mobile, and is from mobile it will notify it is open or subscribe to the analytical service. So this is the how the flow will work, and we have taken care of all the problem with the single point of failure, scaling problem, and the performance bottleneck. So this is all about the high level design for the notification service. So please subscribe my channel to get to know more about the high level design, no level design, and interview tips and tricks.